The API project type is one of the most powerful web project types in .NET. Instead of relying on a person to interact with it graphically, the API project type can be interacted with from other applications or directly from a person. This allows the API project type to support microservices, client-side projects like Blazor WebAssembly, mobile application types like .NET MAUI, and even regular projects like WPF, WinForms, or Blazor Server. In this video, we're going to look at what an API is, what comes out of the box, and how it operates. We'll also compare minimal APIs to regular APIs. Now, if you don't know me, my name is Tim Corey, and it's my goal to make learning C# easier. I do that by providing videos here on YouTube multiple times per week. Plus, I have a weekly podcast. I also provide courses on C#, web development, and much more at IamTimCorey.com. The profits from those sales are what pays for the free content here on YouTube, so that everyone can have a great education in C#, not just those who can afford it. In this video, as with most of my videos, I'm going to create some source code. If you'd like a copy of that source code, use the link in the description. All right, let's go over to Visual Studio and I'm going to create a new project. Now, here I have my filter set up for C#, all platforms, and the web. And there's multiple different web project types, as you can see. There's lots built into Visual Studio, but the one we're going to choose is the ASP.NET Core Web API. This is built upon ASP.NET Core, and that's important because you need to understand what ASP.NET Core is. It's kind of a foundational set of tooling that allows us to build lots of different web project types. So Blazor Server is built on ASP.NET Core. Razor Pages built on ASP.NET Core. MVC is built on ASP.NET Core, which also means that we can incorporate multiple of these things into one project, not just one solution. So just note that a lot of the things you're going to see, if you're familiar with other ASP.NET Core project types, these will be very familiar because a lot of them are the same. So we're going to see what the API has, but just note that if you're familiar with the web project types already, you'll see a lot of the same thing. So let's choose API and hit Next. And we're going to call this our API demo. We'll call this the API demo app. And we'll hit Next. And this is going to choose .NET 6 for our framework, which that's the latest one as of the recording of this video. If you have a later one, go ahead and choose that, although there might be some slight differences. Authentication type, we're not going to choose authentication for now, but we are going to make sure that box is checked for configure for HTTPS. This is the defaults. We're going to keep the defaults, but I want to kind of point out what each of these things does. You can also use the little blue icon here to give you a little bit more information. That goes back to Microsoft's old school documentation. This is where documentation is hard because configure for HTTPS, the description is configures HTTPS. That's not exactly helpful. But just know what this does is it makes sure that your website, your API, which is a website, but it's an API, it redirects to HTTPS instead of just using the HTTP. Very, very important for any website, but especially for an API. We're not going to enable Docker support, but what that would do is it would create for us the Docker file to generate a Docker container from our API that we built. We're not going to uncheck this box yet. We're going to use controllers. We'd uncheck this box if we wanted to use minimal APIs. We'll see about that in a little bit, but for now, we're going to use just the controllers. Next up, we're going to enable Open API support. So this is the newer word for Swagger. This has become an industry standard. This is not a Microsoft thing. This is an industry standard thing. And Open API is going to help us document our API. It's going to help us with generating clients for our API and more. So we're going to use this. We're going to see how it works. And in the future, if you want, you can extend and make this even bigger and better. And we're going to talk about how you can do that. And the final one, again, we're going to leave the defaults here. Do not use top level statements. That's set to false. We do want to use top level statements. That's the program.cs file is not going to have the namespace or the class name or the method name in there because of the fact we don't really need to have all that stuff in there. It's just kind of boilerplate stuff. And so Microsoft has moved away from that, and we're going to continue to not use top level statements. But if you wanted them back, you could check that box. Let's hit create. And once this gets created, what we're going to do is kind of just look over what the API is out of the box. So we're going to pull this up. We'll go ahead and close out the that page that comes up. And out of the box, let's just run this just to see if we don't do anything else. We hit run, what's going to happen. So let's wait for this to launch. It's going to build out our API. It's going to download any NuGet packages we have need of, and then it's going to launch a web page, which remember I said at the beginning that an API can be interacted with via the user interface, actually a human interacting with it, or another application can talk to it directly. We're going to see how to interact with it as a human. And the first thing here we see is that this is Swagger, which I called Open API. That's the newer name for it. They are used interchangeably as of now, but in the future, it will probably become just Open API as the name that will be used throughout the industry. So this is our API, which we actually have some stuff on here. We have the weather forecast, which we can hit by clicking this, and we can try it out. We can say execute. And notice down here, we get back a weather forecast by clicking this. We're going to talk about what all this stuff is and how it works, but out of the box, this is our API. Now, this is a whole lot more fun to look at than if we looked at what the API would look like without anything. Okay, page that you found. And if we did /API, nothing there either. But if we went to weather forecast, like so, that's what the API looks like if you call an endpoint. And again, not terribly useful as far as from a user's perspective, from a human perspective, because that gives you the data, but it's hard to read, it's hard to understand, and you're not quite sure what's going on. Well, that's where our Swagger comes in. The Swagger, let's zoom back out to default. That's what basically overlays on top of our API to make it look good for the user so they can easily understand how to navigate our API. You see, I didn't know, or I had to know how to go to the weather forecast endpoint in order to get that weather forecast data. So if I didn't know that, how would I even know to go there? Well, I wouldn't. But this is where the documentation comes in, where it says, hey, you got an endpoint at /weather forecast. If you call that, then you'll get back the weather forecast data. So this documentation is very, very helpful. It comes out of the box. There's a lot more to dive into. For example, it covers the schema, the data structure of what will come out of weather forecast, the date, the temperature in Celsius, temperature in Fahrenheit, and the summary. And that's per record. Also notice that there is this JSON file right here. If we click on this, this describes our API. It documents it, but it documents it in a way that other applications can read. It's a JSON file. Well, this can be used to generate clients for our API. We'll talk more about that in a little bit. And finally, up here, we'll see there's a drop down here for version 1. That's all that's in the list. But that kind of indicates there can be more than one version of our API. This is a very important thing to know how to do. Versioning APIs is very important. If you're building an API, you'd want to have version 1 because it's the first one you're building. But as soon as you put your API into production, well, what happens when you want to make a change to your API? Well, if that change is in any way going to break existing clients, that's a problem, because now you have to make sure that all the clients have the new fix, and that can be pretty overwhelming. That's why we version our APIs. If we're going to make breaking changes, meaning not just changing the logic, but changing the path. Let's say I didn't like /weather forecast. I want it to be /weather forecast with a zip code or a postal code in order to identify where the weather forecast should be. Well, that's a breaking change because we'd be requesting additional information on this endpoint that we didn't before. Well, that could crash applications because they don't have that additional information to give you. So that's why we have versions of our API, so we can actually adjust and change our API over time. We can deprecate things, but not turn them off, so that we can have new clients use the new stuff, but the old clients are still supported while we go through the upgrade process. So versioning is super important, and we'll talk a little bit more about that. So that's out of the box, just hitting play. But what is an API? Why do we have an API? Let's talk there first. So there are times when you need to have a tool that gets data for you. Remember, applications really revolve around data. That's the sole purpose of about 99% of all applications. In fact, you might think, well, I know there's exceptions out there. Yeah, there probably are some exceptions, but very, very few. Even games revolve around data. So when we look at building an application, an API can be a very, very powerful tool because it can sit between your user interface, your graphical user interface, and the data. This way, we can have one central point that securely accesses and modifies and filters and gets all the data that we need. And we can get data in a way that maybe some clients can't. For example, if you're on a mobile application, .NET MAUI, for example, or Blazor Hybrid, those mobile applications shouldn't talk to the database directly and usually can't talk to the database directly. And the reason why is because the client has all the code on it. Well, imagine if you have to use a password to talk to your database, which you should. Well, where does that password live? If it lives in the client, which is where the code lives, that's a problem. But if the client can access that password, then it's the same as if it lives in the client. Therefore, you've got a problem because now you're giving your database password away to every mobile user you have. Or client side, if you use Blazor WebAssembly, that all the C# code lives on the client and can be visible and viewed by the client. That will include anything like app settings.json, which we don't typically have in Blazor WebAssembly because of that. Because now those settings would be on the client and they'd be fully exposed. You may say, well, I can encrypt it. Yes, but if your client has the ability to decrypt that information, which they'll have to, well, then the person that owns the client will have the tool to decrypt the data. Therefore, it's not secure. So we build APIs to sit in the middle. And we can go down the rabbit hole of why APIs are more secure. They are, because basically the shortest answer I can give you is because you can log into the API using your credentials. They're yours, but then the API can use the database credentials to talk to the database. That's the shortest answer I can give you. There's a longer, more thorough answer as to why that's the case. But the API can serve a really big role in mobile applications or client applications. If you use Angular, React, or Vue, if you use one of those JavaScript frameworks, well, they also use APIs to get their data. And yes, a JavaScript application like Angular, React, or Vue can talk to a C# API. So there's some power there. If you watched the Timco Retail Manager series here on YouTube, you will know that we built an API to talk to our WPF application. But then later, when we built a Blazor WebAssembly application, it was just user interface work because we already had all of our logic, all of our data access in the API. We reused the same API for both WPF and Blazor WebAssembly. Some really cool stuff. So APIs can be hugely helpful in software development. But how do they work? Well, first, it's a web project. So let's look at program.cs and just see what's in here. If you're not familiar with, let's dismiss this for now. I don't really care. If you're inside of program.cs, you'll note that this is the same as other ASP.NET Core project types. If you're not familiar, let's walk through the basics of it. We start off by building our web application. And then we start with adding dependency injection. So there's our controllers. That's for our API. We'll look at controllers in just a minute. Then we have our API Explorer. That is Swagger. So this is more information about our API, and so is Swagger Gen. So we have information about our open API. We have our controllers. That's all going into dependency injection. And then we build our application. So we start by creating the web application. Then we build it down here after we have all the services. And then we can start doing work with it. So for instance, we start by saying, hey, if this is the development environment, then we're going to use Swagger and use Swagger UI. Now, this is only going to allow Swagger to be in the development environment. That is, if you're running in development. By default, you're running in production. But if we look at under properties, launch settings.json, we'll see that the environmental variable sets the ASP.Core environment to development. And down here, ISExpress sets the environment variable for ASP.Core environment to development. So both IES and also Kestrel use the development environment. They specify that. But when you launch this when you publish this to a web server, you don't have these commands anymore because these are just for launching locally. Therefore, you're going to not have that setting. When you don't have the setting, then it assumes production by default. So right now, this is configured to only be in development, meaning only when you're running it locally. In a lot of cases, you don't need to have this if statement. Just always include Swagger and Swagger UI. In a lot of cases, you do want that documentation in public. But it's up to you. And by default, Microsoft says, hey, we're going to make this as secure as possible. Therefore, we're not going to allow the documentation for your website or your API to be visible unless you're in development mode. But for the most part, again, documentation should be available for your client. Therefore, usually what you do is take off this if statement, but keep these two lines. Here is our HTTPS redirection. So if you go to the website and the HTTP version, it's going to redirect to the HTTPS version. We have the ability to use authorization, and then we map our controllers before we finally run. So this one right here, what it's doing is weather forecast. Let's look down here. Oh, not this one, sorry. Under controllers, weather forecast controller. There we go. So we have this idea of a controller. Notice it inherits from controller base. And the program.cs, when it says map controllers, what it's going to do is look for any controllers that are around, and then it finds out what is the path to use. That's the route right here. And by default, this one says the route is just the controller name, which is weather forecast. That's why we have /weather forecast as our route, which is not typically what we do with APIs. Typically with APIs, we have something like API/controller that allows us to have that URL be maybe for a website, but if you have the /API path, now you're into the API portion of it. So by default, Microsoft puts it right in the root. I'm not a big fan of that. I like to have the API in there. And if we were to run this now, this will change the path, because when it loads those or maps those controllers, it's going to figure out the paths are. And notice now it says /API/weather forecast. So if I were to take this URL and say API/weather forecast, I get the weather forecast data. So the path comes from the route. So that's the route specifies. And then what does it call? How does it know to call a method in here? Well, we have the HTTP GET. So it's saying a GET command, and the name is get weather forecast. So that's the call. So we have our API/controller, but notice I didn't actually put get weather forecast as the name. And that's because we're doing the way that the API works. And again, we're going to touch just on the surface of this, but we use the HTTP verbs. We have get, post, put, patch, delete. Those are the common ones. And so for a get, that's what you do when you have a URL. So when you are calling an API on the web and you just put it into a browser and say API/weather forecast, like so, this will be a get command. So because it is a get command, it comes down here and says, oh, I have an HTTP GET for this controller. That's what I'll call when you put that into a browser. In order to do other commands like post, put, patch, and delete, you really have to use something like Postman or another tool to make those calls. Yes, you can kind of force your browser to do it through the developer tools, but the easiest thing is to use a third-party client of some kind. So that is the basics of routing. So we have our route name here, which again, we can modify, but it's a string. And this right here gets replaced with the name of your controller. And then we use the verbs, which we don't have to give it this name. This name is for ease of documentation purposes and other things, but we don't have to give it that name. We can just say HTTP GET. We can set a route for this particular endpoint. So you can say that this one's going to be at this specific route, but typically we try to leave it alone and not do that because we want to keep our things clean and simple, conforming to a pattern so that our APIs are predictable. Even though we have documentation with Swagger or OpenAPI, we still like to have that predictability. Okay, so that's the program.cs. That's the process of building and running our API. And we know that this right here, map controllers, this is going to look through and find all the routes that we have and put those routes into our documentation and set things up so that we can use those endpoints. Now, there's a lot of code in here. Microsoft made a bit of a mess with their demonstration. This is demo code, obviously, but it's kind of a messy demo code because it's not even following great practices, which I'm not a big fan of. But what we have here is they have this array of data. This provides the ability to generate those summaries randomly. So we have our logger for logging. Our controller, that's their constructor, which just gets the logger. And then down here is where we do the actual work, which is doing the work right in the controller. Again, I'm not a fan of that either, but it is a demo. So the work they're doing here is they're doing a 1 to 5 range. They're doing a select, and we say, take today's date and add from the range from 1 through 5, then get a random temperature, and then get a random summary. And then you might say, where is the temperature in Fahrenheit? Well, if you go look at the actual model, which again is in a horrible place, but the temperature in Fahrenheit is just 32 plus the temperature in Celsius divided by 0.5556. So that's how I get the temperature in Fahrenheit, which actually means the temperature in Celsius to Fahrenheit conversion. That's actually correct. So the temperatures will at least be in relationship to each other correct, but the rest of the stuff is all just random data that we're using. So let's create our own controller just to see how you create a controller. So let's right click and say add. And the controller is one of the options here. So let's choose controller. And then do not choose MVC controllers. This is not about an MVC project. This is API project. And in here, we're going to choose, let's choose the API controller with read-write actions. And the reason I choose this is for a couple of reasons. First of all, it's going to create for us a bunch of different options or actions for us to see, but it's also going to be a great template to use to kind of make it ours. So choose this one. Do not choose the using entity framework, and don't choose the read-write endpoints. We're going to choose actions because we're using controllers. We're not using minimal APIs. We'll see that in a minute. So we hit add. And it's going to say, okay, what do you want to call it? And let's call this users. Users controller. Make sure you leave controller on in the name and put it in the controllers folder. These are conventions to follow. Hit add. And now let's look at the users controller. So we're going to get rid of the code comments here. We don't need that. And then notice by default, it puts API/controller. That's the actual standard for APIs, or the thing that normal APIs do out of the box. That's kind of the industry standard, which is even more distressing. They did not do that for this one by default. I had to add this, which I wish I just followed their standards. But notice it's marked as an API controller and it inherits from controller base. These are both important to have. And then we have a bunch of different methods. We have a get method. Notice it's marked as HTTP get. We also have a get method with an ID. And notice it even tells us what the path would be. Now, it puts this in angle brackets, users controller, but notice the path is /controller, which is users. So the actual path is going to look like this. Okay, so just note that their documentation is pretty good, but not perfect. So this is /users. We'll just call this, but notice this one takes in a parameter. And so here's how you would put a parameter into the URL. And so now if you call this path right here, API/users/ and then a number, that will call this one. And then we have our post. Now call this. Then we have our put, and we have our delete. So this is how you would build out a full API controller. Now you can notice, let's just clean up these so you can use them or see them later and understand what each of them, how to call each of them. Now notice that this gives you a good kind of template for how the various API endpoints might look or actions would look. So we have how to just have a generic get where you just say, get me all the data, and it gets you all the data. And then how to filter that or limit that and say, I want the /users, but I want just this user, number 5, and how to get just that user. Now ignore the code itself because this is just demo code. But then we have, here's how you make a post command. Here's how you'd make a put command. Here's how you make a delete command and how each of those might look so that then you can take this and build out an API that works for you. So with this, I haven't made any changes besides just cleaning up the documentation. So let's hit run. I just added this and notice we already have more documentation. We had just weather forecast, but now we have users. And if we do a get for the users and try it out and hit execute, you'll notice that we have value 1 and value 2 being returned. And if we do /user and try it out, it's going to say the request body is a string. We hit execute and it says success. That's for the post. But if we do a get with the user/ID and try it out, it says, hey, you need to put a value in here. Let's just put 4. And it says the return value is value. Not very helpful, but if we come over here and say, let's do string interpolation here, and let's put the ID at the end. And let's put a space before it. Hit save. And now we run this again. Notice the hot reload has already reloaded this. So I pass, let's say, try it out. I pass in 4 and execute. And then down here it says value number 4. Because that's what I passed in. If I change this to 87 and execute, it says value 87. So we're running our code. And obviously you get to choose what that code does, but this is how you would pass in a data for a get command. Now, the question might come up, okay, how do I create a REST compliant API? And this is a term that gets thrown out a lot. REST, if you're not familiar with REST, it's a poorly understood standard for APIs. If you want to be fully 100% REST compliant, good luck, because it's almost impossible. In fact, the original REST definition was, I believe, a theoretical paper that a person created for, I think, their doctorate. But we've taken that and really there's a lot of great stuff in REST. The biggest stuff, if you want to be, generic and very high level with REST, the idea is that if you have /users, then you'll get all of the users. And if you have /users/5, that gives you a specific user. And you follow the same pattern where you call the same endpoint with different verbs or with different modifications, and it gives you other things. And so at the very simplistic view of it, REST allows us to have better, more consistent APIs. Instead of just saying, this endpoint is get all users, and this one is get some user. That would be more confusing. Whereas this is more of a clear cut, this is how it works. And again, I'm totally oversimplifying REST, but that's the very basics of some of what REST does. And so, yes, this by default will give you some really good tools to make RESTful APIs. How far you go down that road is up to you, but here's my encouragement to you. Don't get so stuck on a standard that you hurt your API. Because sometimes you have to step out of what is a fully RESTful API in order to make one that is simpler or one that is more logical. And so just be very careful not to get so caught up in a term that you forget that you're creating an API that has to work and work well. So that's my thought on that. So this is how you create controllers with actions. So this is kind of the standard, the regular way of creating APIs. But you may have heard about minimal APIs. And you may say, Tim, what's the difference? Well, let's see the difference in action. Let's right-click on our solution, and we're going to say Add New Project. We're going to choose an API project again. We're going to call this our minimal API demo. And we're going to uncheck this box that says Use Controllers. So uncheck that to use minimal APIs and hit Create. And now let's close out everything from the original API and go over to minimal APIs. Program.cs. Okay, this pretty much looks the same. So we have Endpoint Explorer and Swagger Gen. The difference is, and let's bring this other one up here. This is the old one. We had add controllers. We don't have that in minimal APIs. We have build, and again, that's dependency injection right there. So we still have Swagger in development. We have HTTPS redirection. We have the boilerplate code. Microsoft, don't put it there. But we can get rid of that. And then we have app.mapget. and it's mapping the weather forecast. And that code probably looks familiar because that's the same code that was in the weather forecast controller right here. So why they put it right in here? Well, app.mapGet is going to map for us an endpoint. Think of it as a controller's action, but we're making it simpler than that. And then it says with name. So we can name that get weather forecast just like we named it in the weather forecast controller where we said the name is get weather forecast. And app.run. So we're missing a few things. And by the way, there's the record, which what they're using instead of using a model, they're using a record, which kind of makes sense in this limited perspective. But I wish they wouldn't have put it right inside of the program.cs because it makes it look actually messier. So let's just set this as the startup project and run it just so you can see that when you run it from an end user's perspective, it's no different. Okay, from an end user perspective, we can say try it out, execute. It still runs, still gets data. It still looks exactly the same. And that's important to understand. Minimal APIs have nothing to do with the end user. The end user will not know that they're calling a minimal API versus a regular API. So there is nothing to do with the end user. This is all about how the code gets written. That's really what it revolves around. So why do we have minimal APIs? Well, in a minimal API, notice that we don't have a controllers folder in here. We don't have models like the weather forecast. Maybe we do have the record down here. They kind of smushed it all into one, but even so, there's a little less stuff going on. And even in the weather forecast controller, we have all of this stuff that really supports this. Whereas in the minimal API, we just have this one line of code. Now, it's not saving a lot right now because it's really set up kind of poorly. But the idea is that we can do instead of setting up controllers and having the routing find it and setting the routes up for everything, like we have the route here, or in user controller, we have the route and we have the path and so on. Instead of doing all of that, we just say app.mapGet, here's the path, and then here's the code. And notice it's mapGet. We can also have map post and map put and map delete and all the rest. But the idea is app.mapGet map post. Let's do map post. You could say / testing, and then we can have some kind of code. Now, what they did was they put the code in line. They put a full method, anonymous method, right here. You can put your own method here. So if you had a method somewhere else, you could put that in right here and make it a whole lot cleaner. I have a whole video on intro to minimal APIs that shows you how to do this and how to make it very, very clean so it's very, very understandable what your minimal API is doing and not putting everything into program.cs, which I am really opposed to. I really like to have that separation because program.cs should be just about the control center for configuring and launching your API. When you have configuring and launching and also doing the logic of your API, that's where messes happen. But let's just say we put our code here, and our code is just something as simple as that. That's an endpoint. And so if we were to get rid of Microsoft's stuff, let's get rid of all the boilerplate stuff, and these code comments can go as well. Like so, we can get rid of this, we can get rid of that, we can get rid of that. Let's get rid of their endpoint, which is a good example to show you what you can do, but you don't need it. So now, notice there's only one file of code. It's just program.cs, and really our API endpoint is just one line Let's run this. It says post testing. Try it out, execute. It responds hello world. Probably a post shouldn't be responding with hello world. It should probably be a get. So let's change this because let's do it right. So there we go. We have, there's our get, and we can say try it out, execute, and it says hello world back. That's a working API. And even with the extra blank lines to make things easy to read, I have 18 lines of code. So why do we care about this kind of what looks like code golf, the idea the less lines, the better? Well, actually, this is really, really helpful in certain circumstances. This can be very, very helpful for if you're creating microservices. In microservices, we don't have massive APIs. We have tiny ones. We have ones that do one thing. They might have 1, 2, or 3 endpoints, and that's it. Well, why would we have a whole controller with all this stuff when it's doing just a little bit? And why would we have one controller and API and then have all the configuration of that controller and then program.cs, map the controllers, and then add the controllers, then map the controllers, and all the rest when we don't need all of that stuff? We could just do it all here. That tends to make more sense because we have less lines of code to maintain. It's simpler to understand where everything is, and it's a simple little API. You can create an API that has full CRUD access in 100 lines of code or less, and yet make sure it's very, very clean and not just code golf crunched together to pretend like we're doing something cool. So if you look at the intro to minimal API video, you'll see more about that. I create a full CRUD access minimal API. Now, the question might come up then, well, why would I ever use my full controllers versus this right here? Well, if you're going to create a full API that has what would be lots of different controllers, let's just say 5 or more, then all of a sudden you'd have a little bit more of a mess here with your mappings. And that would tend to make more sense to have your controllers be there instead of this. But really, if you organize it well, there might not be a reason not to use minimal APIs for even larger APIs. But it makes sense to have both options so that you can choose what works best in your circumstances. Now, I am going to give you some words of wisdom. I'd like you to listen to these best practices. Don't put your method here. As in, don't put your code of your method here. Call a method here. Okay? So put a method call here and put your method somewhere else. Because it's not good to put everything in program.cs. That's the idea of following solid and following the single responsibility principle and thinking through, how do you just reduce complexity of your code? Don't put your code here for every endpoint. Have a logical place to put it other than program.cs. When it comes to building controllers, same can be true. Okay? Don't put your code in the controller, in the action. Don't do it. Put your code somewhere else. Okay? Just have the action specific code, meaning, checking to make sure that the object is valid. That can be action specific. And then alerting the user or sending data back to the user. That's user specific or action specific. So it might be in this spot, but the actual logic, the actual data access, all that stuff should be somewhere else, probably a class library. The cool thing is, if you do that, then switching over to minimal APIs should be a piece of cake because you're still just doing the same thing. You're calling another method. So either way, minimal APIs or full controllers with actions. Either way, you shouldn't put your code in the the API itself and the controller itself. Instead, move it out into a class library or somewhere else that makes sense. And then I want you to think of the fact that the API is a user interface. And people kind of push back on that and say, no, Tim, a user interface, I can click buttons. No, that's a graphical user interface. That's a GUI. This does not have a GUI, but it is a user interface, even if that user isn't a person. So I want you to think about this as if it's a user interface, just like WPF, just like Blazor Server, just like MVC. Those are all user interfaces. So my recommendation is always to move business logic, data access, that type of code out of a user interface into a class library. The same is true for an API. Move the code that's not user interface specific out of the user interface into that class library. So that's some best practice recommendations for APIs, whether it's a minimal API or the full API. There's lots of stuff you can do here. One thing I want to point out is if we look here at Swagger Gen and Swagger UI, these are all defaults, but there is a lot you can configure with the Swagger instance. For example, the versioning. So you can version your API. It's very easy to do using Swagger UI. And then also documentation. You can improve your documentation of your API through using code comments. So over here, if I were to say // I can create these XML comments. And notice if I do a / here, it even picks up the parameter name of ID. Well, if I comment this and then set up Swagger, I can have Swagger read these comments and put them into the documentation on the Swagger page. So really cool stuff there as well that you can do with Swagger. There's a lot of configuration you can get into with just Swagger itself. I have a whole section on Swagger or OpenAPI, whichever you want to call it, in my API course, because there's a ton you can do there to really make your API work well. Also, you need to think through things like caching and routing, caching and also rate limiting of your API. That way you protect your API against overuse or abuse. And again, there's a lot of stuff built into API. We don't have time to get into it in this video, but that full course covers it. I'll cover it in some other places as well. But if you want to get into learning APIs, you need to understand how to do that as well. So make sure you know how to log, make sure you know how to protect your API, how to document your API, and so much more that comes with API. But I tell you what, if you're just getting started, APIs are an amazing place to start learning. And in fact, it's one of my top web projects to learn because of the fact that it is so versatile. This can give data to any other project type. So even if that project type could directly access the database, by going through the API, first of all, you add a layer of protection, which does slow things down a little bit. So you have to balance that. But the other benefit is you can have multiple user interfaces that are very simple because they're just user interfaces and they talk to the API for everything else. So you can have, if you start off with just a desktop application, but have an API that gets the data, well, then it's very easy to add a mobile app later or a client-side web application later, or to have multiple of these things at the same time. So having an API really opens up a lot of doors. It's not for every project, but when it's useful, it's really useful. So I would highly encourage you dive deep into the API project type, whether you're going to be a web developer or not. You should know how the API project type works and how to build one. All right. So if you have questions, leave them down in the comments. I will try to get to as many as possible. If you would like to see more about a particular topic in API or another topic in C#, go over to suggestions.imtimcorey.com and leave a suggestion there. Also note, If you haven't already gone there, go to the www.csharpprojects.com. This site covers all the different project types that come from Microsoft out of the box, and you can look at, hey, where does this fit? Okay, so API right there in web. Now notice that it says I have an introductory video to minimal APIs. I'm going to put this intro video there, but also the learning path to learn more about APIs. But it's also, hey, I'd never heard about gRPC. Well, go ahead and watch the intro to gRPC. It's a great technology as well. And it's similar to an API, but does things a little differently. So you can watch that and see what the differences are. Put one more tool in your toolbox. I highly encourage you to use this page and don't just focus in on the one project type you think is quote unquote best, because these are like tools for your toolbox. Different tools do different jobs well. And so you don't just add one tool to a toolbox, you add multiple. So knowing how each of these works is important. And for almost every single one of them, if you click on it, there's an introductory video. These are free videos that you can go and look at and understand what it is, how to get started, and how to go a little deeper into that topic. You can understand if you want to learn more about a particular topic. It's really important that you understand the various projects available to you in Visual Studio and which ones would work best in every situation. So I encourage you, use this tool, make sure you understand the different project types and kind of grow your knowledge so that you can be a more well-rounded developer. All right, thanks for watching. As always, I am Tim Corey.